Hello everybody, this is Li Pan from Norchain.io. In today's video, I'm going to introduce our newly open source project Neunity. Neunity is a project targeted to set up a toolset for the new smart contract developers to increase the efficiency of development. Basically, what you need to do every time when you make a change for your logic is to try to deploy your smart contract to a nested net. Which means that you need a connection with a remote testnet, apply for some gas, or at least you need to set up the private chain on your local machine, which is also battery consuming. So is there a chance that we can just put the smart contract as a part of the client logic so that we can put the breakpoints and test the case in there, like offline application? And that's also what I'm going to show in this video. It also has a lot of other features, but we will introduce that later. Download the Unity. I'm using a Mac. Maybe on the Windows, maybe the process is a little bit different, but let's try the Mac version first. So we're gonna launch the Visual Studio. Okay, let's create a new project. It's just for the testing purpose because that's a very important thing for the new smart contract developers. What we're gonna do is to create, you can select from others, we select the .NET, and from the right side, we select the Unity library project. And we put that project onto the desktop with a name like, let's say that test smart contract, and create. There you go. It will review the design, see the structure of this project. Also, you will see the folder is on the desktop now. We open it, create a new folder with the name of Neunity. And from here, that's the Neunity project to be downloaded from the GitHub. We just open it and copy a couple of things over there. The first thing, adapters and apps and tools and contracts. The smart contract, new smart contract has a lot of restrictions on the language features. And for example, for the type converting, the byte array concatenating. So our basic idea is to put the adapters there. For the same operations, we can, on the client side, we can use the Unity one. We just delete this one. That's the meaning of adapters. Adapters means that the different platforms taking the different implementations for the same interfaces. Okay, so we keep these ones. And now, this is the design. In this folder, it's still not there. So we need to manually add these folders into the project structure. Add existing folder. Okay. Newly open. Check them all and exclude reference. Okay. Click OK. Choose add link to the file. So now we see all these files over here. Okay. And most of the files are just used as the libraries. The only thing we need to change is this one. Under the folder of a contract, we have the smart contract.cs. Okay. And still, we need to add some references over there. Add the references. Okay. We're gonna we're gonna check the neo.smartcontract.framework. And I think we also need some big integer. It's right here. Let's search for it. It's numeric system dot numeric. Okay, there you go. And we get it compiled. Okay, now on the left side, we can see that all these folders are in the structure now. And in this file, this is a place that you were supposed to put a logic here. Right? We already have a very simple template, and because we have a sample application, we just copy and paste the whole thing. Okay. As you can see in this template, we have the main entrance with 3 basic functions. The arguments, we have 2 integers, a and b, and we have 3 operations, add and minus and divide. We put that into 3 functions, okay? And the 3 functions are supposed to calculate like the 2 integers, add and minus and divide the operation, and return with a response. That's a point. That's one feature of the Neunity framework. It's optional as well. Of course, you can directly return the result as a big integer into your DApp, but you will see the advantage of putting that into a standard response transfer protocol. That's a new TP. For this framework, we are using some very similar structure as the HTTP. We will see that later. So for this example, we have the 3 operations, and the next step is to write some test cases to test it. So we launch this one. Okay. And for test case, we just put that side by side. Okay. In the test case framework, we are going to use the Neunity using Neunity tools. Okay. Neunity adapter app. Okay. Neunity adapt and use the Unity one. Okay. So for the first test case, we are going to test the operation of add. So we put that add here. Okay. So for example, if we have an object array with a parse, it's a new object array with number of 2, and we just test it with the parameter 0 equals to 1, while the second one equals to 2. So how can we interact with the smart contract? There are a couple of ways. The first way is to, because this function is public, right? So if you want to test that, you can directly using a, say, a byte array. Okay, does the return value equals to the contract dot add the parse 0 and parse 1. Okay. And convert that thing into the big integer. That is the first approach, but there's a better one to better simulate that we are interacting with a smart contract. And this approach, okay, instead of this one, is to use the npTP dot response equals to the nu contract dot invoke with a response. This endpoint is used to evoke the same logic from different places, say the storage, local testnet, and maybe some other test and mainnet. Right? And for the second one, we put add here. The third one is the arcs, the paras. Okay. And for the response of this message, we just put the response dot body. That's a body which can be directly converted into the binary. Okay. And because we also know that the return value as a body is supposed to be the big integer. So we just convert the byte array into a big integer. And from here, we're not supposed to the native conversion method because it's in the front end, and the actions such as as integer something, right? That operation is not available because it's a front end. It's not supporting all the features from the new smart contract. Okay, so instead of which we are using adapt operation of bytes to bit integer to convert it. Oh, sorry, bytes. Okay, bytes. So since this is a test case, we just put the comparison between these two things, right? 1 plus 2 should be 3. Okay, there you go. So this is the first test case we put in here. Asset dot r equal. Okay. And we're gonna run it. I know this one would crash, but I'm just trying to demonstrate what's going on. It will fail. Okay, the reason why there's a failed it's also some questions when you are developing, right? If the smart contract is on the private net, you may not be able to easily figure out why it crashed or why the test case is failed. You put a breakpoint here and debug it. Then we can further track in. See, the breakpoint is now inside the main function, right? That's our target. So with one step, it crashed. So it means that the problem is happening here. So it's like the conversion from the object to big integer has some problems. So now we get to know, oh yes, we are not supposed to directly use an integer here. It's a big integer. So what we can do is like using the big integer with this one. And also for this. And the result should be 3. Okay, let's run this test case again. It's passed. Okay, so it means that this function is working well. The add function is working well. That's good. So from this example, you can see that how we can put a breakpoint into the smart contract logic to test the basic functions. It's very, very convenient. And then I'm gonna further demonstrate another example, which is the divide. It's much more complicated than the add one because we have an invalid value, right? And here you will see the power of our transfer protocol, the Neunity transfer protocol. Why we get that there? Okay, so the test, you can test divide. Okay, we can basically have similar things here. The parameter. Okay, so for the parameter, we also have two parameters, and the first one say we have a 5, and second one 2, right? That's also a question maybe a lot of people want to ask. What happens for the big integers when the 5 divides by 2? Some people may say that comes to 2 or maybe 3, right? So, depending on different rounding mechanism. We just put that into the divide. Okay, parameters, and see 5 divides by 2 if say if it's 2. Okay, what's happening? Ignore test cases not equal. Oh yeah, because it's not a public one, sorry. Okay, let's try to run again. Okay, it's passed. So it means that the result for 5 divided by 2 should be 2. Okay, that's the valid case. And now the new part is coming. Let's test the divide invalid. Okay, and in this test case, we are going to put the second parameter to be 0. And everybody knows that when the 5 divides by 0, we come with an invalid value, right? As a service of this function, we should throw out some exception. But without a standardized way, we are not supposed to do that because you know that all the return values of the neo smart contract are just the byte arrays or big integers, right? So the problem for that is that we cannot identify if the return value of a smart contract is really some valid value or invalid response. Okay, and here we can see the power of power of our transfer protocol. Okay, as you can see that in the smart contract logic, we put into two branches. The first one is that we see if b equals to 0, right? We just respond with uh, with a bad request, assert for the return value, right? We can also compare the response header. Okay, say the header, the response header has a code, and if this one equals to nutp.code dot, this is the way that we are imitating as a HTTP service, right? And in the headers, we put that the back request. Okay. So rather than just judge the return value, okay, we also the return value actually it's not going to be valid one, okay, but it should be 0. It should be 0 because in our response, you know, the body field of the response equals to 0. The return value convert into the big integer should also be 0 as well. And we run the test case. Okay, it's also passed. That's cool. So we can add more test case over here to do the test-driven development for our smart contract. It's very important if we want to grow the logic of the smart contract blockchain application to be even large scale. So once we successfully tested all the functionalities in our smart contract, the last thing we are gonna do is to compile it into the AVM file and upload it into the real test chain environment for the final test. And in order to do that, we need to follow the document on the NEO's official site. It's right here. Okay, this page. It goes through the very detailed steps of how to do that. I'm not gonna repeat this process. Um, As a project I already have set up, its final is following this instruction. Okay, and you can see that for the final ASC project, we are pretty much using the same files we were using in the test ASC project. The whole structure, Neunity, adapters, apps, contract, and tools, right? But the only difference is in the adapters. As you can see from the right side, the test ASC project and the folder of adapters, we are using multiple files in order to get it compatible with the local environment. But for the project of final ASC, our target is to compile the final smart contract. So we are using the new.cs as the adapter. And one more thing we need to mention is this flag, the new ASC flag, the macro. We need to turn it on because if it's off, in test ASC it was off, right? So it was using this namespace. But now we need to turn it on in order to get it compatible with the adapter.new. Okay, and to turn it on, what we need to do is to open the final asc.cs project. We open it, and you need to define the constants in the property group with the name of NeoAC. That's the only thing you need to put in there. Okay, and let's try what will happen. Okay, we delete all the things under this building folder. Okay, now we get back into the project file and build it again. There we go. This is the final AC.dll real here. And we go to terminal, we run .NET. Okay, it's successful. And in the folder, we can see the final AC.avm. There you go. So in this case, I want to introduce the Neo Combiner Echo. This is very convenient, and you know that usually we need to set up the private chain by ourselves, but Neo Combiner is doing a very fantastic job to make it easier for every developers. Okay, so usually what you are doing is like paste your smart contract code into this box and compile it, and go to Network Essential to deploy it and invoke it. But in our case, this time, we're not gonna compile from here, right? We just import, upload AVM from our ones. Okay, this one successfully imported. And then we go to Network Essentials. So we can see deploy the smart contract. Okay, you can see the log -100. Don't worry, it takes long time. The block generation speed is much quicker than the usual test nets. It takes seconds. That's just be patient. And then we're going to test this one. Okay. Okay. There's a test array adding two numbers. So the first parameter is a string parameter with the value of add, and the second one we're gonna put the integer of the value of 1. Okay. And the third one is integer. Oh, wait a second. The second one should be an array. Sorry for that. Okay, just check the parameters to be correct one. Okay, we copy the whole thing and okay. The first one is add, the second one is the array with two integers. Okay, everything goes fine. And we're gonna invoke it, see what will happen. Okay, it's hot. So it means that the test is successful. Okay, we can see the result is the head of Neunity. This picture shows our future plan. We have the orange boxes for the internal development plan, while the blue ones stands for the interaction with the open source projects from Neo's ecosystem. So let's take a look at the adapters layer first. We plan to interact with the Neolux RPC because the demo you see in this video just now is just the interaction with the local storage. If we plan to use the client code without any change to interact with a real chain, we also need some integrations with Neolux. And the second component is about continuous integration with NeoCompiler echo. So in that way, with only one click to run script locally, you can compile and export the AVM and directly upload it to the NeoCompiler system. And the last part on the adapters layer is about chain status delegate. It's also a very awesome plan, which means that you can, on the client side when you are debugging, right? You can call some client-side code to generate a fake block with whatever content you want to put in there, or maybe just fast forward the chain block generation to reach some time in the future in a very short time. You don't need to wait until the chain reaches to the next block anymore. And then let's go to the tool layer. From the tool layer, we plan to integrate the wallet from the Black Hat and the Neo wallet. And we're also trying to enhance the code efficiency because now we are just make it functional, right? But we need to enhance its efficiency in order to consume less gas. And on the application level, we are also working on some guidelines and more examples to make more developers get easier to adopt into the Neo's system. It's a very important thing, I think. Only when there are more talents in our ecosystem that we can make it ever growing. So in the last of this video, I want to tell some background about the Neunity project. Actually, Neunity is a side project when we are developing the game CarryBattle for the Neo's game competition, organized by the NEL and Neo Game. Very appreciate for the organizers' hard work. I met a lot of very great developers who are joining the competition, and we work together to tackle the technical problems and make some awesome games and we made friends. The reason why we developed the Neunity framework for CarryBattle is because that this is a totally decentralized game. We're doing some experimental thing which can put all the logics on chain so the players can play the game without the support from the centralized servers. So the game can ensure that the thing that the players would never lose is not just the digital asset, but also the entertainment experience. The game idea of CarryBattle is also very innovative. We are trying to simulate the famous Byzantine general problem, which is supposed to be resolved by the blockchain today, but not in the ancient time, right? So what you would do if it's in the ancient time and you are acting as a general, you and your alliance plan to siege a city and you get some fake news, what are you gonna do? How can you judge the situation and make the right choice? CarryBattle as a card game will simulate the whole thing, and hopefully that you can play the best choice with the open message you can retrieve from on-chain and make your own decision.